this is Elizabeth Clare Brewington with Discover Brightside. We celebrate our birthdays, we celebrate anniversaries, so why not celebrate Earth Day? And we have been celebrating Earth Day not for 1 year, not for 2 years, but for 7 years. This is the seventh annual Earth Day celebration. So happy Earth citizens or global citizens or we are just have a blessing to be on Earth. And I'm very proud to introduce you to our speaker. So, Bill Pekny holds a physics MS and BS degree from Georgia Tech and DePaul, plus a graduate study in physical meteorology and numerical analysis at Florida State and the University of Utah, and a visiting scholar appointed at the Ginzton Laboratory of Applied Physics at Stanford. Bill's career in science spans over 50 years in the U.S. Armed Forces and the aerospace industry. And we want to highlight that he has done Project Storm Fury, U.S. Navy Hurricane Hunters, and applied atmospheric physics and meteorology research. Now, his book is second to none, and I want everybody to know that you will be getting a chance to win. Now, I know Ken already has a book, but for those who don't have a book, you will get a chance to win this wonderful book. We'll be giving several of these books away today, so pay attention. And if you write us a comment, and if you subscribe and you get to know us, we'll enter you into the online virtual drawing as well. So not only the ones in the studio, but also for people who are watching us will get a chance. We also have a special coffee that is made out of a mushroom. It's cordyceps, and it's supposed to give you this amazing boost of energy. Elton and I have tried it. We've reviewed it. We love it. It comes in bold and it comes in caramel flavors with a latte. So and we'll be giving away plenty of these. So someone is going to get a chance to win. So thank you for those in our studio, because this is only for people who attend in the studio. So over to you, Bill. Welcome, welcome, welcome. I am so delighted to have you in our studio today. Also, just a warm welcome to Ken, who has been such a great support of this channel, to staff Reginald Laverly. Thank you so much for your service. And to Colonel Donna Ford, thank you for your service. This is our monthly virtual veteran luncheon where our veterans get a chance to do a little powwow, talk about their books or their products or services. And it's a chance for people to network and get to know one another, because when you network, you meet people and possibly get a sale. So over to you, Bill. Let's see what you have to say.
Well, thank you very much for having me yet again. I really appreciate it, and I'm honored to be here today. So let me go ahead and share my slides, and we'll get started in just a second. Okay. Okay, can you see my first slide now?
Yes, I can.
All right, so this is some of the mainstream media type of things that we are now used to seeing year after year, which is the our weather is changing, our climate is changing, and a lot of it's not true. And so what I'm want to start with is this one. I think this is from uh, Phoenix, Arizona, a couple weeks ago, maybe a month ago. And it's typical, and it doesn't look at what's behind this, the context that goes behind it. And so let me talk about that. So true or false? Was it hotter than ever there? Well, that's the way the conversation goes. But the truth is, when you look behind the veil, is that yes, carbon dioxide, it is a byproduct of fossil fuels. That's true. And it's also a greenhouse gas that hinders air from cooling the normal cooling it does at night. That's also make means the same thing as acting like a blanket to preserve a little of the heat that had otherwise escaped to space at night. And yes, CO2 is going up, but at a steady and beneficial rate, and we'll talk more about that. But the truth is, the real truth is it doesn't make our air hotter than ever. If you look at that thermometer that was on the last slide, um, that's in past years that they're comparing temperatures to, that was typically a mercury or an alcohol thermometer that was providing the temperature data. Now it's electronic, and they're not the same. The electronic thermometers run anywhere between 1 and 2 degrees Fahrenheit hotter, and there are other reasons too that are lurking behind there that I'll talk about as we go through my slides quickly here. So here's we military folks like to start with the back end first. And this is the bottom line, is that there is no climate crisis. The Earth is not about to burst into flames. And we'll talk about that. And here's the agenda that I'll cover for the next 15 to 20 minutes. First, some basics that I really need to say every year just to make sure we're all starting from the same place. And then we'll talk about mainly air pollution and what's changed since 2020, since last year, and these topics, and specifically the endangerment finding. Disclaimer first, I'm retired. I'm not dependent upon anybody uh, for except you all that care to buy my books. I'm not getting any money from or grants or anything else from anybody, not the oil companies, not the energy companies, not anybody. And that's important to say because um, there, the whole topic of climate has been inundated by the alarmists that think we're about to burst into flames. And there's not much talk about the other side that I'm on, what we call the realist side. And that's because a lot of people are afraid for their jobs. And so they don't talk about it as much as the activists, the alarmists do. Anyhow, so that's a disclaimer that I like to show to get things started. So first, the basics. The time-honored scientific method is what we want to talk about first here. And I'm going to have Elizabeth show a 1-minute video here in a minute about, tell you beforehand who this guy is that's going to talk to you for 1 minute. He's a physicist from back in the 80s. He's passed away now, but he was a 1965 Nobel laureate in physics. And he also was the guy that figured out what caused the Challenger shuttle to explode. And it wasn't consensus that allowed him to do that. So let me just let you watch this 1 minute now. Elizabeth, would you please run that video for us?
Yes. Can everybody see my screen?
No.
Okay, hold on. We'll just do it again. Now?
No, I don't see it yet.
Okay, I think
Okay, I see it.
The
or
video?
you'd have to stop sharing your slides. That might work.
Or I can just click it right from here and see if it'll start up at my end.
All right, if you
Go
want to do
ahead.
that.
Now I'm going to discuss how we would look for a new law. In general, we look for a new law by the following process. First, we guess it. Then we, so don't laugh, that's what's really true. Then we compute the consequences of the guess to see what, if this is right, if this law that we guess is right, we see what it would imply. And then we compare those computation results to nature, or we say compare to experiment or experience. Compare it directly with observation to see if it works. If it disagrees with experiment, it's wrong. And that simple statement is the key to science. It doesn't make a difference how beautiful your guess is. It doesn't make a difference how smart you are who made the guess or what his name is. If it disagrees with experiment, wrong. That's all there is to it.
So that was Richard Feynman back in 1965.
The easiest microscope that I have ever used.
Okay, that's not me doing that. Ruth, are you there? This isn't me doing this, Elizabeth. Are you? I can't hear you. We can't hear you.
This is not me. It's not coming from me.
Okay, let me.
This is coming from you. Now it's stopped.
Ah, that was me. My apologies.
It's
I
all
didn't mean to do that.
It's all right.
Okay, let me share my screen again. I don't think you can see it, can you?
No, not yet. Go ahead.
All right. All right, so that's Richard Feynman who was just talking. Can you see my charts now again?
Yes, I can see them.
Okay. So, and what he said is this, it's all about the scientific method. We use cold, hard evidence, not things like consensus and groupthink to do science properly. So moving right along. And here's an example of what we don't do in consensus. Until the early 17th century, we all thought that the sun revolved around the earth. And that makes sense, thinking that, you know, when I get up in the morning, I see the sun rise in the east, and at night it goes down in the west. And it's very easy for people to think, yeah, it's the sun that's going around the earth, but it's not true. And so what's changed? Why don't we believe that anymore, that what we see, the sun going up and down? Well, it's the invention of the telescope back in around 1610 by a handful of guys, specifically Galileo, who were able to look further out into space and discover that no, it wasn't the sun going around the earth. It was the opposite, that the earth was going around the sun. And so it was the telescope that did that, not the consensus of all those people back at the time. So my first point is that we do science by the scientific method. So now some basics. What's the difference between weather and climate? Let's just go over that real quick. Weather is events. It's what's happening in your backyard daily. That is, on a small area, looking at local temperature over a small time frame. I don't believe anything that's more than about 5 days old, by the way. It's just too complex. Climate, on the other hand, is a long-term trend in weather over a large footprint, temperature over a large footprint and over a large period of time. And we're talking about multiple decades here, at least 3 decades, and the longer the better. So that's the difference between the two to keep in the back of your mind always. Control knobs on our climate. Of course, the sun is heating our planet, and where there's plenty of water to go around, 71% of the Earth's surface is covered by water. And if you think about the rotating Earth, it's tilted and the axis is changing, and it's rotating every 24-hour cycle, and it's dragging along with it all that water and the air above it. And then there's gravity that's holding us on the planet so we don't go flying off, and the inertia of the planet itself. So those are the control knobs on our planet, not we humans. We're not deciding what the weather is, except in a very small way that we'll talk about more. Carbon family is another thing that's a misnomer. People talk about, well, it's three elements to the carbon family. The basic carbon molecule C is soot, for example. Carbon monoxide, a very deadly uh, gas, as we all know, is carbon monoxide, and carbon dioxide is a very clean gas that we need for all life on our planet. And I'll talk more about that in a minute. And I think people get confused, a lot of people, because they talk about carbon and they think about that bad gas that'll kill you in minutes when we're really talking about carbon dioxide, which is really the gas of life that I'll be showing you. So I think they get mixed up when politicians and the media talk about carbon rather than specifically carbon dioxide, which is what they really want to be talking about. And here's an example of that. The Earth is greening. This is satellite pictures taken over the past almost 4 decades now that show that our Earth is greening. And the reason it's greening is because of the increasing amount of carbon dioxide in our air. Still, though, the horror show still abounds. The thinks that we're experiencing the warmest temperatures ever and all these other things that I've listed here. And so they want to blame it all on carbon dioxide and spend trillions of dollars to figure out how to do away with it, which is impossible to start with. But so now let's talk about air pollution, because I promised that we'd focus on this a bit too today, and it applies to everything we've talked about just to this point. So what's in the air that we breathe? These are the good gases here. And as you can see up here, 77% of what we breathe in every second is nitrogen, and another almost 21% is oxygen. And down here is carbon dioxide at 4/100ths of a degree or a percent. And then there's water vapor. The other that goes anywhere from in the deserts at near 0% volume fraction to 4% in very humid climates. So these are the good gases, along with a bunch of trace gases. These are the pollutants. And there's carbon monoxide that I mentioned earlier. These are the major pollutants that we see, and especially the ones coming out of volcanoes. We see ozone being a good gas on one hand and a bad gas on another. It's the ozone that's up high in our not troposphere but stratosphere that blocks some of the ultraviolet coming in from the sun so that we don't get sunburned too easily. So it helps us up high. It blocks some of the ultraviolets that causes sunburn, but it's bad nearby. It is a pollutant. It's especially bad in places like Utah, where I am in the winter. And so these are the bad guys here. And those are the gases that are bad guys. These are the particulates that are the bad guys, and lead is there, and then there's this thing we call particulate matter 2.5, meaning it's less than 2.5 microns. So what that is dust and smoke, is smoke specifically. Oops. And then the other one is particulate matter is particulate matter that goes up to 10 microns in diameter, and that's dust that's blown across where the Great Salt Lake has shrunk a bit and things like that. So those are the bad guys. But we've made a remarkable progress over the years in controlling pollution compared to when I grew up in Chicago back in the 1950s and 60s. And these shows all of those things that I was showing on previous slides and how they've evolved over time. And they're all doing much better than before, thanks to things like catalytic converters on our cars and things like that. So we're doing a good job on pollution, but we still all need to be good stewards of our planet and even do better. So now let's talk about the endangerment finding for a minute. And this has to do with carbon dioxide and the fear that back then, and this is the 2007, 2009 timeframe during the Obama administration, when there was a Supreme Court case that called greenhouse gases, including carbon dioxide, pollutants. And it resulted in a determination by the EPA in 2009 that carbon dioxide poses a threat to public health. But it was based on consensus. And like I said before, consensus is no way to do science. The truth is, and this consensus suggested these kind of things. Now, the realists and other scientists that believe the way I do tried to get that done away with over the years, but didn't succeed. And it went all the way up to the Supreme Court, who declined to even review the endangerment finding and passed the buck off to the Environmental Protection Agency, which kept it into effect until 2 months ago. When they finally, real scientists finally got it across that it's unaffordable and expensive, that it was all based on computer models and consensus about those models that don't match the scientific method, reality, real measurements. It's based on unproven science, like this carbon capture is trying to suck carbon dioxide out of the air and bury it in the ground. It doesn't work. It's tried, but not doing very well. And there's zero verify. Again, here's the scientific method saying there's no evidence that carbon dioxide is harmful. And it's plentiful and it's reproducible. And it is a good gas. You know, that one I showed that shows that the planet is greening. It's a part of the processes that our plants use, the photosynthesis, to provide food for us, that it's beneficial to all life. And it also, the agreement that happened back in 2009 was very costly, or would be very costly, to get rid of carbon dioxide. And that's supposed to require congressional approval, but they never bothered with that before. So 2 months ago, a little more than 2 months ago, it was finally rescinded by the Environmental Protection Agency. And I was just at a conference a couple of weeks ago in Washington, D.C., where they had Lee Zeldin, the head of the Environmental Protection Agency, talked for an hour about this and some of the lawsuits that are evolving that they're dealing with now to keep this law rescinded so we don't end up spending trillions of dollars. And the net zero policy goes hand in hand with that. And it's also going down in flames now that climate change is finally being viewed as, in the truth, that it's a hoax. And that's because carbon dioxide is not a pollutant. It's beneficial and has been proven by the scientific method to not be harmful. Big Brother water vapor is also one of the gases, and if these were allowed to stand, or if this was allowed to happen to get rid of these, our planet would be perpetually frozen, 0 degrees Fahrenheit. So these two are preventing excessive cooling. It is that airborne fertilizer that's in the air that's causing the plants to grow as well as they are. And so it is a food, and it's an oxygen generator for the oxygen part of what we breathe through the process of photosynthesis that takes the carbon dioxide in the air and the water vapor and the water liquid from the roots in the ground uh, on the green leaves and creates the process of photosynthesis to create the food that we eat. And it's heavily saturated in the air, carbon dioxide, even if we double the carbon dioxide. I'll show you a slide on that in a minute. And net zero is not feasible. Trillions of dollars are to not do anything worth doing, to detect a little tiny bit of beneficial warming to the tune of 15 hundredths of a degree Fahrenheit. So we need the CO2. We need more of it up there, not less. This is just a comparison of temperature and CO2 history. CO2 is a zigzag blue line. The red line is our backyard temperatures as a function of time, and then the climate, the trend part of it is that black line. Let's talk about human respiration for just a minute to even prove the points further. Again, we saw that the good gases that we inhale every minute of every day are that number of parts per million, mostly nitrogen and oxygen. What we exhale is a little bit less nitrogen and a little bit less oxygen that's converted to carbon dioxide, as you see right here. So we're generators of carbon dioxide, and it's not bad, it's good. And here's a clear indication of the goodness. I'm going over time here, so I'm going to go finish up quickly here. As you can see, as it climbs, so do crop yields, and it's across the board. The greenhouse effect, real quickly, is the sun radiates, warms the earth during the day. A bit of it's reflected by clouds back to space. At night, the earth cools by emitting infrared radiation back to space. But some of it, because when there's greenhouse gases in the air, is reflected, is absorbed and re-emitted to preserve the blanket effect, the ability of the earth to not cool too much. So that's the way the greenhouse gas works. And here's what happens. This plot here shows the parts, the concentration of CO2 in the air. And we're right around here right now. This is that law of diminishing returns. If we double the amount of carbon dioxide in the air, it would to 800. It wouldn't change much in terms of that warmth that we're losing back to outer space at night. And if we double it again to 1600, again, it doesn't affect that blanket effect. And it's just that law of diminishing returns. So CO2 is saturated in the air. It doesn't matter how much of it we put up there. It's not going to kill us. It's going to help us. And just for a little perspective before I finish, we're over here in time. This is 160 million years ago. And we're near a CO2 famine. We've gone up a little bit, as we showed in previous slides, but nothing compared to the way it used to be, or nothing the way it needs to be for an optimum for plants. We're doing better, but so that's the bottom line on greenhouse gases. It's greening the earth. It doesn't generating heat. It's just preventing excessive cooling. Just real quickly, there's in blue, that's carbon dioxide versus wildfires. The trend is flat. They're not increasing. They're not going crazy thanks to carbon dioxide. Same's true for tornadoes, killer tornadoes in particular. Again, that's carbon dioxide increasing, but not affecting the flat line of trend of tornadoes. Same's true for hurricanes. They're flatlined. They're not getting worse. It seems that way to a lot of people, but carbon dioxide isn't causing it when they have these blips. And then the heat waves the same. These big spikes back here, uh, the the no, what's it called back in the 30s and 40s that happened.
The Dust Bowl.
Yeah, the Dust Bowl. Thank you very
Yay.
much. Okay, so I'm done. We need to be good stewards of our planet. We need to keep it clean. We need all forms of energy, but be careful on renewables because they're expensive and they're not 24/7. Our climate and our weather, they're both always changing, as I hope you've seen from the evidence that I presented earlier. And what I'm really worried about at times, and I want our youth, the kids, to know that you don't need to be afraid of climate change. We're not going to burst into flames at any minute. Just study it, respect it, prepare for it, and adapt to it. And enjoy that warm hand that Mother Nature's dealt us. So let's not waste trillions of dollars doing something that's not going to change our temperature very much at all. This is me. If you need to get a hold of me, if you want to buy the book, there it is. Here's a couple of where a lot of what I've gotten comes from. These three websites are really good at the source material for why what I've been saying is true. And now I'm also working on a second book, and it's just my plug for that. It's coming soon. I hope to be done by the end of the year and doing it the same way. I'm self-publishing it through that same publisher and printer, and hopefully that'll come out. And this is just going to be 20 short stories about what I've done over the last 57 years, from all my weather stuff to splitting atoms and other things. So that's it. Questions? Can't hear you.
We're going to hold the questions.
Okay.
Just because we want to do a deeper dive into this. First of all, everybody, please give Bill a big hand because it's not easy to put these presentations together for us. So thank you. And if you're watching on Instagram or Facebook
Very well done.
or wherever you want, write us a comment. Tell us what you think about what Bill has to say, and we look forward to launching his book on the website when it's ready. So thank you, Bill. And I'm going to bring Donna for. I know Chip has to leave. So Donna, we will try to get you in and get Chip next. All right. So, Bill, if you can stop sharing your slides.
Let's see. There we go. Sorry about that. I'm
And we
sorry
have
for taking up too much time.
No. You were always a pleasure. Every time I listen to you, I learn something new. No, not at all. In fact, we've got a lot of academics coming up, so we will save our questions for the academics.
Okay.
Dr. Jackie runs my academic group, and she is working with math literacy. We started off with saying that because we have so many authors, we want people to read more. And then Dr. Jackie came in, and now we're adding math literacy. And then Donna reminded me that this is the financial month. So we tied it all together, math, earth, and literacy. So I'm going to stop recording for a minute. You're watching Discover Brightside. Make sure you hit the subscribe button.